Hello everyone, my name is Greg and I dev stuff. Welcome everyone to the third episode of the GODOT engine tutorial. In this episode we will start learning basic coding and implement movement to our rigid body. So in this episode we will start doing coding for our games. As I said before, I will be using C# rather than GD script. To properly move your character, we need to change our rigid body into kinematic body. Then, after that, you select our kinematic body, and in the inspector, at the very bottom of the inspector, you can see script. Click on the empty field and click New Script. Select C# and name our script. I will call it character control. It will automatically open the script after you're done. You can notice that at the right side of the rigid body, in the scene dock, there is a new icon, which looks like a piece of paper. That means that this node has a script attached to it. Of course, you can right mouse click in the file system and create new script here, but doing this the way we did it is way more convenient, because GODOT will pre-generate everything what you need to get started. Good, let's read our script from top to bottom. At the very top you can see using keyword with GODOT and system. For now, just remember that you need them. We will be exploring the using keyword later on. Then you can see the class which will be storing our code body. Class must be called the same way the file which is storing our class description is called. Then class must inherit from the class of the node to which it is being attached to, so in our case it is rigid body. Just begin our tutorial by defining a new integer variable. Declare the integer variable following the example. Let's call it x. Then we can have a float type variable. And then you can have like a string. This is not all types of data, of course. It's just an example for time being. We will be exploring more data type later on. Below our newly declared variables, you can see an override of ready notification. Every object in GODOT implements a wide variety of notification methods. Its purpose is to allow the objects to respond to a variety of engine-level callbacks that may relate to it. For example, the one we have here is called ready, which will be called at the moment the node enters the scene. Simply speaking, the moment the node is created on the scene at runtime, this ready notification will be called by the engine. There are many more of those notifications in GODOT. We will be exploring them over the course of this series. Good. As a usual tradition, let's make hello world program inside our ready notification. Input GD to interact with GODOT engine, then print, and inside route bracket input the string parameter. When you're trying to write text into the variable or a parameter, you must put it inside the quotes, so the compiler will know where the code is and where is the text. Save the script by pressing Ctrl S. Now if you launch the scene inside the output dock, you will see your text. Attention, if you're experiencing errors at this point, to use C# in GODOT 3.2.1, you must have Net Framework version of 4.7 installed on your PC. I already have it installed, but if after trying to launch the game you get an error, and if you open the monodoc at the bottom and click on view log, you will be able to read the log of the errors. And if the error is about you not having proper net framework installed, this log will show you exactly the version of net framework you need, after which you can easily find the exact net framework and download it from Microsoft website. Okay, good. Inside the output you can see that it shows the text you put inside the quotes. You can put your variable inside the print function to show the values of those variables. And you can combine variables and parts of the text to create complex messages. Good, now we want to detect if our player press any button, or is there any input from the player. To do that, override input callback. Input call notification fires up every time your game receive an input. To be able to process any input, we have to define those inputs inside the input map. To do that, click on the project on top, then settings, inside select input map. Inside you can see a list of currently mapped input to action. Action represents the generalized name for the input. This allows you to have more control over the input mapping. For example, if you want to have multiple buttons to be mapped to the same action, but don't want to directly call and check for each of the possible pressed buttons, you simply check for the specific action. And if any of the mapped buttons are pressed, then this action will be able to fire up if you are checking for this action in your input system. Let's add forward action. On top you can see a text field. Inside you can write a new action name. Let's write control forward and click add. Click on small plus sign to map the input to this action. For now simply choose a key and press the key you want to be mapped. Now let's map the basic WASD control scheme. After we are done, close the window. Good, now inside the input, let's check is our forward button pressed. To do that, call if input is action pressed, then write the action name you want to check for. Is action pressed will check the input continuously, which means if the player holds the button, this check will be true until player lifts off the button. If you don't want this and only want to register the input the moment it is being pressed, use input is action just pressed. Good, now as the last touch, let's make character movement. To do that, let's declare a new variable called velocity of type vector3. Vector3 represents the position or vector inside the 3D space. Simply speaking, it is an expanded array of 3 floats, each responsible for the position on one of 3 axes inside 3D space. Let's rename our float variable into speed. And add vector 3 variable called gravity with default value of vector 3 down multiplied by 9.8f. Now inside the input nullify the velocity on x, z axis. So every frame it will reset itself. So our body will be able to stop. Then use is action pressed to form the direction of the movement. Later on we will be using the axis control to move our character. Now override physics process with parameter float delta. And inside first apply the gravity multiplied by delta to the velocity. To make your object fall down. Then call move and slide with velocity parameter and save what move and slide returns into the velocity back. If we launch the game now, our cube should be able to move around. And because our spheres does have rigid body, we can push them around. This will be it for this episode. In the next episode we will start implementing logic into our game. If you have any questions or any recommendations, please leave your comment below. If you are interested in seeing what will come out of this, please subscribe. If you want to support further, you can find my Patreon in the description. With best regards, see you in the next episode.